Now I know what you're thinking. You're thinking, I wish these roots were more complicated. Well, wish granted, let's go. So we're now going to focus on using this alpha, beta, gamma, delta method of looking at polynomial roots. And we're going to start with a couple of quadratics, which are quite nice to do so. And one way around they can ask these questions is they can give you the polynomial, in this case 2x squared minus 5x minus 4 is 0, tell us it's got some roots, and then we want to find the value of some related sums. So what I would recommend you do at the start of any of these questions is write down your values. So we've got here obviously a is 2 and b is minus 5 and c is minus 4. So if we put that all together, that would tell us that alpha plus beta is equal to 5 over 2, because it's minus minus 5, and alpha beta is equal to c over a, so that's minus 4 over 2, so that's equal to minus 2. And do that before you do anything, because everything else is going to be manipulating using those expressions. So if we're looking at here, we've got a, we just need to literally write down it's 5 over 2. For b, we just need to literally write down it's minus 2. Then we get to something like 1 over alpha plus 1 over beta. Now this isn't something in our formula, so what we need to do is convert it to a form that is. And we're going to do that by giving it a common denominator of alpha beta. That means I need to multiply the left-hand equation by beta and the right-hand equation by alpha. So I'll end up with alpha plus beta on the top, so that's 5 over 2, and alpha beta on the base, that's minus 2. If we then do that calculation, that'll give us minus 5 over 4. And then lastly, you've got this part D where it wants us to find alpha squared plus beta squared. Now you can't obviously just take that expression and square it and get that. But we are going to take that expression and square it and see what we need to do. So alpha plus beta squared is equal to alpha squared plus 2 alpha beta plus beta squared. And if we are to write that a little bit nicer, it's equal to alpha squared plus beta squared plus 2 alpha beta. Now, is this useful to us? Yes, it is, because we know what alpha plus beta is. We've worked that out. It's 5 over 2. So we can rewrite this as 5 over 2 squared is equal to alpha squared plus beta squared. And we know that alpha beta is minus 2, so we can say this is minus 4. So we're basically there, because we just need to square, obviously, our fraction to add our 4 across, and we'll get our alpha squared plus beta squared, which is 41 over 4. Okay, let's have a look at another quadratic. So the other way they can ask this question is that they can give you the roots and tell you to work out what the quadratic was that you started with. Now in this case we don't actually have a pair of complex roots, which is good. We've got roots minus 3 over 2 and 5 over 4. Now there are two ways that I think you can do this. We're going to do it using the classic alpha beta method first though. So for starters we could work out what alpha plus beta actually is. This is minus 3 over 2 plus 5 over 4. So it's going to be minus 1/4. And we know that's equal to minus b over a. Alright. We can also say that alpha beta itself is equal to minus 3 over 2 times 5/4, which will give it as being minus 15 over 8, which is equal to c over a. What we tend to want to do here is to just say, well, what about if a was 1? What would happen here? Well, that would tell us that b would have to equal to 1/4 to make that top expression work, and c would have to be equal to minus 15 over 8 to make that expression work. And that'd be okay, but we want integer values, so we need to multiply these all to make that happen. So our biggest denominator is 8, so let's times them all by 8, and that'll give us that if a equals 8 and b equals 2 and c equals minus 15, then this expression should actually work. So our solution should be 8x squared plus 2x minus 15 equals 0. You get the idea. So I quite like that little cheat. So you obviously work out your expressions and then just say a is equal to something and take it from there. Now another way of doing this would be to treat this as, okay, let's work with factors. If these are our roots, then our factors are going to be some multiple of k plus 3 over 2 times, x plus 3 over 2 times x minus 5 over 4. And we could expand that out. We could say we've got overall 3 over 2x minus 5 over 4x minus 15 over 8. We could then simplify that all together and get ourselves to plus a quarter x minus 15 over 8. And then we'd have to realize that, so that means k is equal to 8 to make this work. So we've got 8 lots of x squared plus a quarter x minus 15 over 8. So in other words, 8x squared plus 2x minus 15 equals 0. Two valid ways of getting to the same answer there. I'd probably recommend this left-hand side method because it's going to scale better when we look at cubics and quartics, but they both work. Okay, let's look at some cubics. So here's the cubic version of the first question we considered. We'll have a is 2, b is 3, c is minus 4, and d is 2. And like I said last time, work out your expressions first. Alpha plus beta plus gamma. And to be honest, we should probably get in the habit of using that sort of terminology, but we'll stick with it for now, is minus b over a. So it's minus 3 over 2. Alpha beta plus beta gamma plus alpha gamma is c over a, so that's equal to minus 2. And alpha beta gamma is equal to minus d over a is equal to just minus 1. Then we just need to look at the questions and think, well, how do we get these? So the first three of these are obviously just a case of read stuff off. That's minus 3 over 2, that's minus 2, that's minus 1. The last one, we're going to do what we did before and give it a common denominator, which in this case is going to be alpha beta gamma. So we're going to need to put it together like that. And then we can look at the top of that fraction is something we've already worked out as being minus 2. The bottom of that fraction we've already worked out as being minus 1, so it's just equal to 2. Just as a side note, you could also be asked to find the value of something like alpha squared plus beta squared plus gamma squared, and I think it's probably worth just expressing how we do that. It's very similar to what we did before. We would need to square alpha plus beta plus gamma. Okay. Now if we do this, you're going to end up with a lot of terms. Okay, we'll get alpha squared plus 2 alpha beta plus 2 beta alpha plus beta gamma rather plus 2 alpha gamma plus beta squared, and I think plus gamma squared as well. Yeah, that should be everything. And what we can do is we can tidy that up to being alpha squared plus beta squared plus gamma squared plus 2 lots of alpha beta plus alpha gamma plus beta gamma. And we also know that's equal to alpha plus beta plus gamma all squared, because that's how we got it in the first place. And then we could substitute in the values that we found. So we know that this is minus 3 over 2 squared. We know that this is the thing we're trying to find. And we know that this would be 2 lots of minus 2, so this would be overall minus 4. And we could therefore work out that our alpha squared plus beta squared plus gamma squared was equal to 9 over 4 plus 4, I guess, so 25 over 4. Yeah, just be aware that that could be asked. And again, turning our expression round, we have unknown cubic, but we have the roots, and we want to find the integer values. Now, like I say, one way of doing this is to actually expand out x minus alpha and x minus beta and x minus gamma, and it'll work. It'll take a while, it'll be a little bit messy, but it'll work. But we're going to take the alpha beta method here. So we know that alpha is equal to 1 minus 2i, so let's do the sums, shall we? So first, alpha plus beta plus gamma, that's equal to 1 plus 1 plus 2 is 4, and minus 2i and 2i cancel out, so that's just equal to 4. We also know that, and I'm going to start writing it in this form, that the sum of the alpha betas is equal to 1 minus 2i times 1 plus 2i plus 2 lots of 1 minus 2i plus 2 lots of 1 plus 2i. and I could work those out as being, I think it's 1 plus 4 you'll get from that first expression, plus 2 minus 4i, plus 2 plus 4i, the i's obviously cancel out, and we'll end up with that being 9 overall. And lastly, the sum of the alpha, beta, gammas, well, that's just alpha, beta, gamma, is going to be the three things times by each other, and we already have worked out that 1 minus 2i times 1 plus 2i is 5. We kind of did that here. So this is equal to 5 times 2. This is equal to 10. So what's the point about this? Well, we know that 4 is equal to our minus b over a. We know that 9 is equal to our c over a. And we know that 10 is equal to our minus d over a. So if a was equal to 1, then that would tell us that b was equal to minus 4, that c was equal to 9, and that d was equal to minus 10. And they are all integer values, so we don't need to do anything else with it. So we could give our final answer as being that the cubic we started with was x cubed minus 4x squared plus 9x minus 10 equals 0. Okay, so I thought we'd finish off and look at a full exam question here. We're given a cubic with some bits known and some bits unknown. We're not told any of the roots, and we have to sort of work with it. So, as I say, best thing you can do at the start of any of these questions is to write down your sums. So we know alpha plus beta plus gamma is equal to minus b over a. So that's our c is equal to, our b rather is equal to p, and our a is equal to 1. So this will be equal to minus p. Our sum of the alpha betas, so that's the second expression, is equal to c over a, is just equal to 6 over 1. And then our alpha beta gamma is equal to minus d over a, is going to be equal to minus q. I have to make sure that doesn't look like a 9. So going through these one at a time, if we want to write down the value of the sum of the alpha betas, that's literally something we can read off the expression, and we want that, it's a single mark. So part B, we're told P and Q are real, okay, so they're whole numbers, and that alpha squared plus beta squared plus gamma squared is minus 12. So why have we got 2 non-real roots and 1 real root? And this is an explain. So there are 2 points here. The first one is we know that they are non-real because the sum of squares is negative. So if we've got that, then that implies that there's at least one negative, not even one non-real root. And our second point would be that this is a real polynomial because P and Q are real numbers. So we can say this is a real polynomial. And that would mean that there are pairs of non-real roots. And if there's at least one of them and they have to go in pairs, this would tell us that there are 2 non-real roots. Now, I hate writing, as you can tell. That's probably like the least amount of explanation you'd need for 2 marks. And then for part 2, we want to find the value of P. So I'm going to try and be squeezing this all over the page, I suppose, but let's do part 2 over here, shall we? So how are we going to do this? Well, we know alpha plus beta plus gamma is minus P, so it's going to be something to do with that. And I think we're going to use what we looked at on the previous page, which is that what do we get if we square this? Okay, so we looked at it before and we got alpha squared plus beta squared plus gamma squared plus 2 lots of the sum of the alpha betas. You go back a page and check that if you need to. And that's stuff that we can substitute things into, We know alpha plus beta plus gamma is minus P, because that's one of the things we'd written at the start. We know alpha squared plus beta squared plus gamma squared is minus 12 because they've told us that in the question. And we know the sum of the alpha betas is 6 because we've been told that, so it's 2 lots of 6. Now what does this tell us? This tells us that P squared is equal to minus 12 plus 12, which is 0. and so the value of p must be 0 as well. Fairly unsatisfying conclusion, but that's where we are. Lastly, we're told one root of the cubic equation is -1 plus 3i, and we want to find the other two roots. Now, if we want to do this, there's obviously a couple of ways of doing it. We do know that, let's call that alpha is -1 plus 3i, and we know beta is -1 minus 3i, and we know that the sum of the roots is 0. So we know that alpha plus beta plus gamma equals minus p, which is 0. So if we add these roots together, and we know gamma is just some real number, let's call it k, then we'll get 0. So if we add alpha and beta, we just get -2. Gamma is just k, so that would tell us that k is equal to 2. Really not a lot of work you need to do for these marks, is it? And lastly, we need to find the value of q. So q is equal to, or rather minus q, is equal to alpha, beta, gamma. So that's going to be equal to -1 plus 3i, -1 minus 3i, and then times by our k was 2. You should probably get in the habit of knowing that if you multiply complex conjugates together, it's just the first number squared plus the second number squared, so that's just 1 plus 9 when we expand it out. It's sort of like a difference of two squares, but with a plus rather than minus. And so that's 10 times 2, that's 20 is our value of minus q. So our value of q is equal to minus 20. Okay, so that was a full question. Let's just quickly check the mark scheme. So you can see it's obviously very cut down. They've got 6 for the first one. They've got the negative sum of squares and the real polynomial. They work out the sum of these things squared and then get to p is 0. And then obviously we've got our complex conjugates, third root is 2, and yeah, we get -20 for q.